Hi, Anthony Carruthers, Better Lesson Master Teacher Project, talking about how I help students to see structure in this lesson. So we're at the point where we're trying to show that the perimeter of a regular polygon as a function of its radius approaches 2 pi r as n approaches infinity. So we have derived already the expression for the perimeter as a function of r. It's 2rn sine 180 over n. And when students see an expression like this, they tend to just freak out and see it as a big computation. What I want them to do is to see it as structure. And structures, I will use the analogy Legos, things that you can hold in your hands, rearrange, move around. So in other words, don't think so much about the computations as we think about how we can manipulate and move these things and see them as structures. So to aid with that, right now I'm using MathType, but this could be done on any editor or even on the board. Um, so in any case, I would say that we want to show that P of R equals, or at least approaches 2 pi r. And since we know P of R really is this expression here, I'm going to copy this statement and kind of revise it. So copy it, and then down here, go ahead and paste it. Okay, so we want to show that, and instead of P of R, I'm going to substitute in this big expression here. All right, so we want to show that 2rn sine 180 over n approaches 2 pi r. And so for students, again, all they see is complication, but I want to focus their attention on our starting point and our end goal and ask them, what do these two expressions have in common? So once they're willing to look at it, students will see that they both have the 2r. So what I'm going to do is copy this yet again. And this time I'm going to rearrange these pieces so that it's a little bit easier to see what I have. So I'm going to, instead of here having 2 pi r, I'm going to put it as 2r pi. Okay. So in that way we can see now that both sides have this 2r here and this 2r here. And if we want to show then that this one is approaching this one, then really what we need to show is that n sine of 180 over n must approach pi, because structurally they're occupying the exact same position. The n sine 180 over n is in the same exact position as the pi is. And they're both kind of adhering to, so to speak, the 2r part of the expression. So in this way, the next step in this lesson makes a little bit more sense. Students understand why we're looking for the limit as n approaches infinity of this expression, n sine 180 over n is supposed to approach pi. So once again, Anthony Carruthers, Better Lesson Master Teacher Project.